Welcome back. We've got a mesh current method with a dependent source now. And they're going to try and throw you off with some negative signs. Okay, they're going to try and fake you out and get you confused. But we'll get through it. So we're given a circuit that has one of these dudes in it, all right, and one of these dudes and a bunch of other dudes. So let's draw these dudes. This is a fun circuit. It's got all kinds of circles and squiggles and stuff. Look at that. The squigglies and all kinds of... So you've got a 25 volt independent source there. You've got a 10 volt independent source here. And then you have a dependent voltage source. It's a voltage source because it has a plus and minus in there, right? And the magnitude of this source is given by minus 3 V phi. And V phi is a voltage that's being measured across this well, it happens to be a 3 ohm resistor. Okay, so there's a voltage being measured across here with this measurement polarity, so that somebody's hooked up a voltage device, a voltmeter, hooked up a voltmeter to this thing, and they're measuring this V phi, and they're sending that information to this guy, and it's amplifying this. So they're freaking you out here by putting a negative sign on here, which just is, frankly, in my opinion, it's just mean, because they could very easily just reverse the polarity on this and call this positive, but they're just putting that in there to freak you out. All right, so the point being, seriously, I guess, is that you try and guess what the polarities are. You try and guess correctly, but you can't always guess correctly. So it's good to be able to handle these kinds of negative signs. Let's see, do I got everything? 5 ohms, 2 ohms, 3 ohm, 14 ohms, 1 ohm. Okay, so we've got these 3 meshes around here, and we'll draw them all clockwise. So there's I1, there's I3, and around this guy there's I2. So they're all clockwise, and it's pretty sort of agrees with stuff. I mean, we've got the positive sign, we've got the mesh current coming out of the positive sign. That's nice. And here we've got the mesh current I2 coming out of this positive sign. That's good. And likewise for this thing. So that's as good as we can do. And let's see, the I3 going around this way would in fact generate this polarity. So that's good. Although this is just a reference polarity that is being used by this guy. It's just how this polarity comes from how the meter was hooked up. It could easily have been drawn the other way, but it wasn't. Lucky for us, it was drawn this way, which agrees with I3. It's really just managing the confusion. Okay, it's just looking out for what might cause trouble later. Why are we here? What are we trying to find? We're trying to find the power in this dude. What is the power in this guy? They're trying to fake you out, but with all these negative signs and stuff. Trying to sneak by you here. Okay, there's 3 meshes. Well, actually there's 4, but we typically don't use the outside mesh. So there's 3 meshes. So mesh current equation 1 is going to be going around this guy. You've got we've got a voltage here, which we'll use directly. Remember, for this method, we're summing the voltages to 0, and those voltages will either be V or they'll be IR. This is going to be a V. This is going to be a V. This will be an IR, and this will be an IR. All right? And you're coming into the negative sign with reference to the loop, coming into the negative sign. So this is negative 25. And you're coming into the positive sign with this guy, so it's positive 10. So those are V terms. Then you do the 2I1 and the 5I1 IR terms. So it's 5I1 and 2I1. Okay, these are what I like to label as the I1 primary effects, you could call it. Once again, for these level of problems, this is still good to write this out. You can get these done without writing these out, but later on this is a good way to keep things straight. We're going to be writing pretty ugly equations, well, long equations later on. Okay, these were the main effects just around the deal. Now we apply superposition on the IR terms, just the IR terms. It's just the way it works. Okay, you don't do V twice. You don't do this thing twice here on the shared voltage source. This is just the way you do it. So it's going to be a 5I3, right? Because this 5 ohm resistor is shared between I3 and I1, and it ends up being negative because I1 and I3 are opposite directions. Okay, then this guy's a shared term, so that's going to be 2I2, the IR term for the voltage drop across this guy. And is it negative or positive? Well, you look at so I1's going to the right through 2, and I2's going to the left. So they disagree, it's negative, right? And these sum to 0. Okay, so just real quick, we went around here, we did the V's and the IRs. Then just for the resistors, we do the IR superposition terms. Okay, so we did 2I2 and 5I3 superposition terms. And they happen to be negative terms because the currents disagree. All right, that's it. That's mesh current method. And then you do that again. So you go around loop 2, okay? Okay, here's where it gets fun. If you don't think it's fun already, now it's going to be fun, okay? If you were wondering when is it going to be fun? Now. So we're coming into this negative terminal, so it's negative. But the quantity is minus 3V phi. That was that. Then we do the 2, the 14, and the 3. So it's plus 2I2 plus 3I2 plus 14I2. These are all I2 effects. This is shared, and this is shared. So you have a 2I1 term, and you have a 3I3 term. Those sum to 0. And the signs, what do you guys think? The sign, it's going to be negative and negative because the what are we doing? We're doing this guy. So the I1 and I2 disagree in their direction through the shared component. Likewise, I2 and I3 disagree with their direction through the shared component. Moving right along, you go around here, you do the 10. It's going to be negative 10 because this loop is coming into the negative terminal. There's the voltage. Then you do the 5, 3, and the 1. So it's 5I3 plus 3I3 plus 1I3. These are the I3 effects. Then these two components are shared with other loops. So it's going to be 5I1. That's the voltage due to this I1 across the 5 ohm resistor. And you got a 3I2. And they happen to work out to be negative because the currents disagree in direction. Okay, if you put this in standard form for solution by machine, you have 1, 2, 3 equations. This one is, take out this I1, you get what? You get, you get 7, right? 7I1 and 2I2 minus 2I2 and minus 5I3 and okay, I don't have enough equations here, so look, all of this stuff, that's 3 equations but there's an unknown in here. This 3v phi is an unknown, is another unknown. There's not enough unknowns, so I need, kind of running out of room here, but I need another equation. You know what? Let's put it over. I need another equation for v phi here. So I can use another piece of paper. So here's where, here, let me write this out. I need another equation because I have this v phi thing floating around in here, and there's too many unknowns. There's I1, I2, and I3, and then there's v phi. So I need to express v phi in terms of something else. Okay, v phi is a reference voltage. Here, I'm gonna draw it out here a little bit more clearly. This is v phi. If I had the branch current, if I had the actual branch current, I could calculate v phi. But right now I have I1 scooting, or I2 scooting by this way, and I have I3 scooting by this way. So the actual branch current, let's call it IA. IA, the actual branch current. Okay, the total, actual branch current is going to be I2 minus I3, because I2 agrees and I3 is opposite. So there's going to be, yeah, that's what it is. I don't know what those are yet, but that's what it is. And then by Ohm's law, V phi is IA3. V equals IR is Ohm's law. So V phi, this reference current that's used by this device up here, so is the actual branch current times the resistance. So this is so V phi is I2 minus I3 is 3. So I don't want to introduce another variable IA, right? So I put it in terms of I2. So that's down here. So V phi is I2 minus I3 times 3. Okay, so now I have 4 EQs and 4 unknowns. Unknowns, all right? So, I'm trying to write this equation in standard form. It should have I1, I2, I3, and then V phi. So it's going to be minus, there's no V phi terms in this guy here. So you do 0 V phi. Okay. Equal 15 when 25 and 10 is 15. So in this guy here, factor out the I1 terms, you get minus 2 I1. Factor out the I2 terms, you get 19 I2. Then you get minus 3 I3. And this has a 3 phi in it, so this is going to be negative gives you positive 3 V phi. Those sum to 0. This guy is going to be minus 5 I1. When you factor out the I1 terms, minus 3 I2, factoring out the I2 terms, and then 9 I3. And there's also no V phi in this guy, and those sum to 10. Then the fourth equation, this is 4. This is EQ4. Fourth equation, 4, is going to be 0 I1s and 3 I2s and minus 3 I3s and 1 V phi. It's basically this equation put in standard form. Okay, so this we can calc. the answers that are spit out is 4 amps minus 1 amp, 3 amps, and V5 spits out, that's 12 volts. So there's a couple of weird gotchas that are floating around now. So I1 is positive, not so bad. I3 is positive, not too bad. I2 is negative. So our original guess of clockwise here turned out to be wrong. That's why this is a negative value. All right, and the other thing to watch out for is that V5 is 12 and you've got a negative sign on here. So there's so many places to screw this up. Let's do this. To do the power in this, which is what we're trying to find, let's just redraw it with actual polarities. So what's really happening in this guy right here? Well, we drew I2 going that way, but it turned out to be negative 1 amp. Negative 1 amp going that way. So let's put it this way and call it positive 1 amp. Okay? Just to avoid that level of confusion, right? We'll just reverse the arrow direction and call it positive. Instead of negative to the right, it's positive to the left up here on this branch. Do that. Then the other thing you could do is this plus minus is going to freak you out. So you could reverse that and call this 3V5, right? Oops, negative. Reverse the polarity on here and then reverse the sign up in here. Do that. Then you've eliminated the negative signs. So the power in this diamond, use IV now. It's just 1 amp, and then the V is given by this thing. It's 3 times 12. Okay, that's going to be 36. And the current direction goes from minus to plus, which means this is delivered. It's a source. This thing is delivering power, is coming into this device. Okay? Fun stuff. Mesh currents, branch currents, the effect of your initial assumptions on polarity. Lots of good stuff. Hope that was useful to you. See you next time. Bye-bye.